All right, get this. We're about to walk through a proof for a $1 million physics problem. But here's the twist. It's all laid out in a rap song. Yeah, you heard me. Welcome to the Dockery proof.
Right out of the gate, the track hits you with this bold command. It's basically saying, listen up. This isn't just a song, this is knowledge. This is something you should literally be scribbling into your physics textbooks.
So that brings us to the central question here, right? What if one of the absolute hardest problems in physics was actually solved in a rap song? I mean, could the super abstract, dense language of theoretical physics actually be explained better with rhyme and rhythm? Well, let's dive in and see. Okay, so first things first, let's set the stage for what we're dealing with here. The challenge? It's called the Yang-Mills mass gap, and this thing, it's one of these 7 unsolved Millennium Prize problems. Think of it like a great white whale for physicists and mathematicians. There's literally a $1 million bounty on the table from the Clay Mathematics Institute for anyone who can solve it, and for decades, nobody could crack it.
So, where do you even begin with something like that? Well, you have to start with the theory's source code. In physics, we call this the Lagrangian. You can think of it as the master equation, the one little line of math that basically tells the entire story of a physical system. It's got all the rules of the game packed inside. And that's exactly what our lyrical physicist, Dockery, does. The song kicks off by laying down the law, literally. It's like step 1 of any proof, right? You state your starting point, your creed, and that's what's happening here. And the song has this amazing metaphor for why this problem is so incredibly hard. It calls out the theory's non-abelian teeth. So what does that even mean? Well, in simpler terms, it means the forces are interacting with themselves. It's not a one-way street. They create this tangled, viciously complex web that makes the math just a total nightmare to solve directly.
So, how in the world do you tackle a problem that's that complex? Well, you don't just run at it head-on. A smart strategist, a brilliant tactician, changes the battlefield.
And that is precisely the move Dockery makes in the first verse. The whole idea is to change the battlefield. You transform the problem into a shape you can actually get your hands on, a space where the math is cleaner and you can see what you're up against.
And this line from the song, it's the key. It perfectly captures the move. It mentions a wick rotation. Now, this is a seriously powerful trick in physics. You basically take time, which we all think of as moving forward, and you treat it like just another dimension of space. It's kind of like taking a whole movie and turning it into a single snapshot. Suddenly your dynamic physics problem turns into a static statistics problem. And that is way easier to work with.
So let's break that down. On one side, you've got the real world, what physicists call Minkowski space. It's dynamic, it's messy, things are always happening. But on the other side, you've got Dockery's map, Euclidean space. Here, everything is static, like a photograph. And by looking at it this way, the math, well, it just gets a whole lot cleaner. Okay, so before we can really attack the problem, there's a bit of house cleaning to do. See, the theory has a lot of, well, redundancies. Think of it like a language with 10 different words for apple that all mean the exact same thing. It's confusing. So you do something called gauge fixing, which is basically just deciding, okay, from now on, we're only going to use this one word for apple. It cleans things up and makes the logic way tighter.
All right, the stage is set. We've moved the problem to a new battlefield, and we've cleaned up the redundancies. Now, the second verse kicks in, and it is time to bring out the heavy artillery. Dockery starts hunting what the song calls infrared demons. These are basically the really tricky long-range effects that make this whole thing so hard.
And this is the toolkit for slaying those demons. It's awesome, really. Each line in the song points to a real, powerful mathematical technique. So when you hear correlations decay, that's about using a tool called cluster expansion to prove that things far away from each other don't really interact. Reflection positivity, that's a super important reality check, making sure a static map can actually be turned back into a valid quantum movie. And area law spoke, that's the smoking gun for confinement, the reason quarks are forever stuck together.
And this right here is the heart of it. The proof establishes something called string tension, a constant force between these particles. And the lyric makes it totally explicit. That tension, the energy that's stored in the field, that's what's giving the particles their mass. You're watching mass literally emerge from pure energy. It's incredible.
So the argument is looking really, really good. But for a physicist, good isn't enough. A proof has to be absolutely airtight, built on an unshakable foundation. So now we're heading into the final verse where all of this gets locked down and made rigorous. The song calls this the lattice grind, which is a perfect name for it. To make the math totally rigorous, you first put the entire theory on a grid of points, a lattice. It simplifies everything. You solve the physics on that simplified grid. Then, just like the song says, you refine. You make the grid smaller and smaller and smaller, and you have to prove that your answer still works even as that grid disappears into a smooth, continuous reality.
So after all that, after changing the battlefield with the wick rotation, after deploying the whole demon-slaying toolkit, after the entire lattice grind, we're finally here, the moment of truth. Did it all work? Can we finally answer the big question? Is there a mass gap? Is there a minimum amount of mass that a particle in this theory must have?
And the song just lays it out, as clear and certain as a mathematical theorem. The answer is yes. It pins that gap down. Delta is greater than 0. The absolute lowest energy you can have in the system is not 0, it's something more.
There it is. That's the answer. The whole proof boils down to this one simple, powerful statement.
So what does that mean? That is the mass gap. It's basically the universe saying that in this theory, there's no such thing as a free lunch. You can't just create a particle with some tiny, almost zero amount of energy. Nope. To even exist, a particle has to meet a minimum mass requirement. But hey, remember, we did all this work on that simplified map of reality, right, in Euclidean space. So the final, crucial step, which the song points out, is to carefully drag that result back. You have to prove that the mass gap you found on the map also exists on the real-world stage of Minkowski space.
Okay, so at the end of the day, why does any of this matter? Well, for one, it proves that Yang-Mills theory, which is a huge piece of the standard model of particle physics, is actually mathematically consistent. That's a big deal. It also explains why the strong force that holds atoms together is so short range. And it gives a rock-solid foundation for why we never see quarks flying around on their own. Oh, and yeah, it might just be worth $1 million.
So that leaves us with this final, kind of mind-bending thought. We just walked through a proof of a major physics problem that was laid out in a rap song. It used art, rhythm, and metaphor to make incredibly dense logic accessible. It really makes you wonder, right? What does it mean when these two worlds, art and rigorous science, collide like this? Maybe the next huge discovery isn't waiting for a new equation, but for a whole new way of talking about it.